Good morning, students. In this video tutorial, I'm going to show you how to run an analysis of variance, or ANOVA test, with a categorical independent variable and a scale dependent variable in SPSS. Along the way, I'm going to show you how to run a box and whisker plot or graph and test for the significance between your independent and dependent variable using an f-test, and test for the strength of your relationship with eta squared. So, this should look pretty familiar by now. We have SPSS loaded up with our Summer 1 Quantitative Techniques Graduate Student Survey from 2012. And let's just pick a couple things that we'd like to try out. Let's take a look here. We have healthcare reform, strongly favored, favor, oppose, or strongly oppose. This question on the survey is asking you how you feel about healthcare reform. And it would be interesting to see how the students that answered this question compare in terms of their expected income in 10 years. Now, ANOVA is a two-step process. You do one test or one action in SPSS to figure out the significance, and then you have to do another action to figure out the eta squared or the strength. But no worries, I'm going to walk you through both of those. To run ANOVA, go to Analyze, Compare Means, and Way Anova. Here you'll have a dependent list and a factor. The dependent list is actually your dependent variable, and the factor is your independent variable. So let's do this. Dependent variable is expected income in 10 years, because we want to see the effect that your opinion of healthcare reform has on expected income. And our factor, our independent variable, is healthcare reform, how you feel about healthcare reform. Click on Options and select Descriptive and Means Plot. Make sure that missing values is checked off as Exclude Case Analysis by Analysis. So, to repeat, go to Options, make sure Descriptive and Means Plot is selected. What descriptives will do is it will run descriptive statistics of your independent and dependent variable, and will give you the mean and the range of individuals for each, in this case, healthcare reform choice and expected income. And the means plot will just make a graph for you. Click OK. And here's the descriptive statistics. We have 3 people in the class that strongly favor healthcare reform, 15 that favor, 2 that oppose, 1 that strongly opposes, for a grand total of 21. The mean, or the average among those people, well, we have 66,000 for strongly favor, 79,000 for favor, 130,000 for oppose, and perhaps you know where I'm getting with this, 125,000 for strongly oppose, with the standard deviations included as well. Here's the means plot. It's a graph. And it's showing us the mean of all of these choices in relation to the mean expected income in 10 years. So already here, we can see that the significance of this relationship is insignificant, because in our class, we're using a 0.05 significant or alpha value for significance testing. If the number for significance on all of our outputs is lower than 0.05, then the relationship is considered significant. However, if the number is higher than 0.05, then the relationship is not significant, and we fail to reject the null hypothesis. Now, this provides an interesting look at our choices. Each individual with healthcare reform, but it's not giving us the range. We have the range here, standard deviation, lower bound, upper bound. The lower bound is the lowest number, the upper bound is the highest number, but it would be interesting to see this as a box and whisker plot. Remember, a box and whisker plot allows us to see dispersion and variance in our data. So you go to Graphs, click on Legacy Dialog, and click Box Plot to do a box and whisker plot. Select Simple and Summaries for groups of cases. Your variable is your dependent variable, and the category axis is your independent variable. So let's put these back. So variable is your dependent variable, expected income in 10 years. Category access is your independent variable, or your opinion of healthcare reform in this example. Click OK. And here's a box on Whisker Plot. Here we have the Whisker plots for every single choice: strongly favor, oppose, and strongly oppose healthcare reform. The center line is actually the median value, and the boxes represent the 75th percentile at the top and the 25th percentile at the bottom. These whiskers represent the high and low numbers in that data distribution, and then the numbers here, 16 and 17, those are considered outliers. So as we can see, there's a general trend that individuals, and this is ordinal, so we can make such a statement, that the more strongly you oppose healthcare reform, the higher your expected income. That is the nature of the relationship. It is a positive one. However, it is insignificant because we did our test, and right here it is greater than 0.05. However, we still have to measure strength. You can have an insignificant relationship, but it could still be moderately strong or even strong. So let's try it out. To do this, go to Analyze, Compare Means, and select Means. Last time we chose Way Anova for significance. We're going to just go to Means for eta squared, our strength test. Here we have dependent list, same old, expected income. Independent is healthcare reform. And then you're going to go to Options and select Anova table and eta. This is key. So remember, you're going to go to Options and select Anova table and eta. When you go to Analyze, Compare Means and Means to do the strength test for Anova. And again, Anova is a categorical independent variable and scale dependent variable. Click OK. And here we have our eta squared, 0.258. And the way to analyze eta squared is to basically say that, and we can see that our eta squared is 0.258. And basically what that means is 25.8% of the variation in our dependent variable can be explained by our independent variable. If we use our rubric of 0.25 and 0.50, this is a moderate relationship. If it's less than 0.25, it is a weak relationship. If it is between 0.25 and 0.50, it is a moderate relationship in terms of strength. If it's above 0.50, it is a strong relationship. So what we have here, summing it all up, is a relationship that appears to be positive in terms of opposition. The more strongly you oppose healthcare reform, the more expected income is going to be in 10 years. That is insignificant because the sig under Anova is greater than 0.05, of moderate strength because eta squared, the measure of strength, is 0.25.